Okay, modeling quadratics, they give you a couple pieces of information. So if you're going to drop a ball from 5,000 meters above the ground, and this is going to model as distance. So time is seconds. If it falls for 10 seconds, you plug 10 into there, you square it, you times it by 4.9, and that will give you how many distance in meters that is traveled. So if you want to figure out the height of the ball after so many seconds, we're going to take the distance that it travels, 4.9 times t squared, and you're going to subtract that from 5,000. So 5,000 subtract the distance that it travels, and you should match that up with C. So this will give you the height of the ball after however long it's in the air. Okay, this one models a kick of a soccer ball. The ball's height is in meters, so this right here is the height, and then this is time in seconds. So if you graph this parabola, I mean it's going to go on forever, but we're only interested in the window from here to here. So which one of these is correctly describing what's going on? So let's go through them one at a time. A, the ball's in the air for 16.5 seconds, so this is when the ball leaves the ground. It's in the air, 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 in the air. Right here it hits the ground, so it's in the air only for 3.7 seconds. So that's no good. The ball reaches its maximum height at 16.5 meters. Its maximum height is right here, so the highest it is about right here, the vertex, which is 16.5, so yeah, that's good. It takes 3.7 seconds for the ball to reach its maximum height. It reaches its maximum height exactly at the halfway mark, so 1.8 seconds. And then this last one, D, the ball is 3.7 meters away from Joseph when it lands. 3.7 is the time that it lands, so it takes 3.7 seconds for it to come back down into Earth. We don't know how far it is, so we don't know D. Okay, another one. The trajectory of a ball tossed from a height of 6 2/3 feet is modeled by the function. So now we're trying to find the window. So this problem right here, they gave us the window. The window was from here to here, and that's all they wanted to look at. Okay, now you need to find the window for the domain. The domain is the how wide, or it's the x-axis. So if you toss a ball, this x-axis is going to be time, how long it's in the air, and the y-axis is going to be how high off the air, so it's the height. So we're going to start right here. We're going to start at time 0. And we're going to go 2 seconds, 4 seconds, 6 seconds, 8 seconds. At 10 seconds right here, you got to shut it off, because at 10 seconds, that ball has come back down and hit a height of 0. So you got to ignore all of this part, and you got to ignore all of this part. So the ball leaves your hand at 0 seconds, but it's already 6 2/3 feet in the air. Then it maxes out at about 12 feet in there, and then it starts gravity pulls on it, brings it back down, 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 then it hits the ground at like 10 seconds. So your window, the farthest left is gonna go is 0, and the farthest right it's gonna go is 10. 0 to 10, but you gotta include them both. So they need to be greater than equal to's, less than equal to's. Okay, number 5, they give you a quadratic, and they want you to find some zeros or solutions or roots. They're all the same thing. So zeros, solution, and roots, they're all the same thing. Okay, in the quadratic formula, if you recognize it's quadratic, you can use the quadratic formula to find the zeros. You gotta identify A, you gotta identify B, and you gotta identify C. And right now they're easy to find because they're all grouped together. So the A is how many squares you got, the B is how many x's you got, and the C is how many ones you've got. So A is going to be 6, B is going to be 21, and C is going to be a negative 12. Then you just plug them in. X equals negative B plus or minus the square root of B squared minus 4 times A times C. All that's divided by 2A. So now I'm going to change this to a number. Just type that in on your calculator. Alright, 21 squared minus 4 times 6 times a negative 12. So I got a negative 21 plus or minus square root of 729, all divided by 12. Okay, now I'm going to see if this is a perfect square. If square root of 729 is a whole number, we're in good shape. And it is. If it was a decimal, then we'd have to factor out all the squares of 729. So we got lucky. This is going to change to 21 plus or minus 27, all divided by 12. So now we got to do this. We got to do a negative 21 plus 27 divided by 12. And we got to do a negative 21 minus 27 divided by 12. So a negative 21 plus 27. Divide that by 12, and we get 1/2. Negative 21 minus 27. Divide that by 12. And this is a negative 4. So here's your two zeros. But they want the greatest zero, so they want this one right now. 1/2 is bigger than negative 4, so we'll go with B. Okay, what is the equivalent of square root of negative 36? Square root of negative 36, first you got to take the negative out, so that's going to be an imaginary. And then 36 is a perfect square, so it's going to be 6 imaginaries. So if you ever have a square root of a negative, take it out as an imaginary. Okay, 7. Which parabola is going to represent a quadratic that has two, we should put two different order pairs with y values. So D is what we're going with, because D, if I try and come up with the order pair for this dot, it's going to be like a negative 8 and 0. And if I try and come up with an order pair for this dot, it's going to be like a negative 2 and 0. So these are the two ordered pairs that both have zeros for the y values. All these other ones, the vertex happens right on the x-axis. So if I try and come up with the ordered pair for that, it's going to be like 0, 0, but there's only one. This one would be like 4, 0. There's only one 0, and that's where the vertex hits it. Okay, 9, which one's got two complex solutions? So you can type these into the graph and look at the picture, because if it's got complex solutions, if you look at a parabola right here, the solutions it's talking about where it crosses through your x-axis, because these are the zeros, these are the roots. So it's going to either have two solutions or the ones we just looked at. Sometimes they have one solution, but a complex, it's not ever going to come touch the graph at your x-axis, so that means the solutions are going to be complex. Okay, so you can graph them all and look at which graph never touches, or you got to look at the discriminant. So on A is 1, B is a negative 4, but C is not a negative 3. You got to move this over. C is going to be a positive 3. And then you plug them in. X equals negative B plus or minus square root of B squared. Negative 4 times negative 4, that's 16, minus 4 times 1 times 3. And this is all you're looking at is the discriminant. 16 minus 12 is going to be 4. So the square root. What is under the square root? This one is safe. This one's going to give you a real answer. But if it was a negative, then that's the one that's going to give you complex solutions. So A is going to work out. It's going to give you real solutions because what's under the square root is a real number. B, let's look at B. B, A is 2, B is a negative 4, C is 2, so x equals a negative B, plus or minus the square root of B squared, that's going to be 16 minus 4 times 2 times 2, and 4 times 2 is 8 times 2 is 16, so this is going to be under the square root, it's going to be 16 minus 16, so that's 0, and that's a real number, so far we're safe there. Okay, let's look at C. So A is 2, B is a negative 4, C is 7. So x equals negative B plus or minus, I just care about this square root. B squared, negative 4 times negative 4, that's 16, minus 4 times A times C. So under the square you're going to have 16, subtract 4 times 2 is 8, times 7 is 56. And 16 take away 56, you're going to have a negative 40. So this is the one we're after, because what is under the square root is a negative. That means it's going to be imaginary, and it's going to be complex because you're combining this imaginary with these reals out here all over 2a. The bottom's going to be 4. So this part's real, this part's real, but this part is imaginary, and that is complex. So complex is a combination of a real and an imaginary. So this part's imaginary, this part's real, but together the whole thing is complex. So we're going to go with C. So what two complex numbers will add and give you 4 times and give you 29? So complex needs to have a real part and an imaginary part. So if they add and give you 4, you know the real part could be like a 2 plus a 2, or a 4 plus a 0, or a 3 plus a 1. You kind of only got 3 options. But your imaginary part could be anything, like plus 10 imaginaries, minus 10 imaginaries. They do have to be opposites though, because the real parts will add and give me 4, the imaginary parts will add and give me 0, and the add and give you 4, so that works. So you do know something about your imaginaries. They've got to be opposites. One's positive, one's negative. Could be negative 20 imaginaries, positive 20 imaginaries. These ones add up and give you 4. So that's what we know. But now they got to times and give you 29. So I'm going to times them. And let's do, we know that 4, I'm going to get a 4 if I do like the 2 times the 2. So I can't do 4 times 4 plus 0, because those will add and give me 4, but I need to times them. And I can't do the 3 plus the 1, because those add and give me 4, but they times, if this was a 3 and this was a 1, they would times and give me only a 3. So I'm going to use 2 and 2. Because 2 plus 2 adds and gives me 4, and it times, oh shoot, I guess it's got to times and give you 29. I don't know what I'm talking about. So we could use any of those. So it's got to times and give you 29, but watch this. If I use 2 and 2, that's going to give me a 4. And then 29 take away 4 needs to be 25. So I want to add and get a 25, so I'm going to, or times and get a 25, I'm going to do 5 and 5. And I'm going to do 5 imaginaries. And I'm going to do a minus 5 imaginaries. So 2 times 2 is going to give me 4. 2 times a minus 5 imaginaries is going to give me a negative 10 imaginaries. And 5 imaginaries times 2 reals is going to give me a positive 10 imaginaries. 5 imaginaries times a negative 5 imaginaries is going to be a negative 25 imaginaries squared. So these cancel out. So I got 4. And imaginary squared is a negative. And a negative negative 25 is going to be positive 25. That adds and gives me 29. So 2 plus 5i and 2 minus 5i. Okay, what's going to be the standard expression of a complex number? The real part's 5, the imaginary part's negative 3. So you always, from your Excel, looks like this. Put the real part first. So the 5 goes here, the imaginary part negative 3 goes here, and that matches up with D. Okay, what's going to be the factored form of x squared plus 9? So you kind of go through these, distribute them, and see which one gives you this for an answer. So A, x times x is going to be x squared. X times 3i is going to be 3ix. 3i times x is going to be another 3ix. And then 3i times 3i is going to be... So it's not going to work, because these are going to add and give me 6 imaginary x. And that's not in there, so I'm going to get rid of A. B. It's not going to work, because if I times the negative 3 to the positive 3, that's going to give me a negative 9, and I need a plus 9. C, x times x is going to give me x squared. X times a minus 3i is a negative 3ix. 3i times x is a positive 3ix. 3i times a negative 3i is going to be a negative 9. And I times I is I squared. And I squared is a negative. So these zero out, and you got x squared and a negative negative 9. So that's x squared plus 9. So that is C.